Yeah, comes on everyone. Let's start off. Hope everyone has gone through the ACK notes. We'll just brief you a bit, but like I said, there'll be no exam today. We'll just be having a class. So people are panicking for the mains exam. It's okay. I do understand. Only 2 days left. Okay, let's go ahead. So just to brief you, what is this complex number stuff? So the main idea here, right? If you have gone through the notes, we have proved, mathematically, we are trying to get a way to convert these resistors and everything into a mathematical representation of comparing an inductance and comparing a capacitor with a regular resistance, right? So when we did that, so this is what happened in phasors. So if you have a function like, let's say, v is equal to v naught sine omega t, right, where v naught is the peak value, we can write v bar. So I am converting a sine function into the vector, which is v naught into angle 0, right? So this v naught represents the amplitude and this 0 represents the phase angle. So to put it simply, if someone gives you, let's say, v is equal to 10 sine omega t plus 60 degrees, the phasor way of writing this is v bar is equal to 10 angle 60 degrees. That's your phasor way of writing, right? Not only this, you can even do this with the complex numbers. For example, if you have z bar is something like, let's say, 3i, 3 plus 4j. Now, be careful here. We are using j, which is root minus 1. We're not using I because we're already using I for current. So the way to write this thing, mod z is 5, and then we know the angle theta is tan theta 4 by 3, which is 53 degrees. So this z bar, which is 3 plus 4j, can be written as, in phasor form, 5 angle 53 degrees. So you can write a sine function in phasor form. You can write a complex number in phasor form, right? And then you have your all regular operations. So if I have to divide something like, let's say, if you have something like z1 theta 1 by z2 theta 2, this will simply become z1 by z2 theta 1 minus theta 2. In complex numbers, remember, cis theta 1 by cis theta 2, cis theta 1 minus theta 2. Similarly, if you have z1 theta 1 into z2 theta 2, this will simply become z1 z2 theta 1 theta 2. For example, let's say we have a voltage ka phasor 10 sine omega t plus, let's just keep it omega t, and let's say the impedance is something like I'll just take this thing only 2i plus 2j. So when I write the phasor form v bar, this will be 10 0 degrees, and this phasor form z will be 2 root 2 45 degrees. So the current I bar is nothing but v bar by z bar, which becomes 10 by 2 root 2 minus 45, which is 5 by root 2 minus 45. This is the phasor form of current. So when you bring it back to the sine function, the current I becomes 5 by root 2 sine omega t minus 45. You're getting how we got the current? So the whole idea is you convert this sine and complex numbers into phasor form, do all your calculations there, as it works like a DC circuit. V is equal to IR, VL is equal to IR. So it all works like that. And then you bring it back to your sine form again. Clear with this? So this was the main theme there if you have gone through the notes. So complex number addition, it is the same thing. Just like, I taught you in this thing, phasors, how to add phasors. I think I taught you in wave optics or something. Told you to refer in SHM. So the idea was that. And how do you convert this thing? So when you see an inductor L, this can be replaced by a resistor whose complex number is j omega L. So the phasor form of complex this thing, XL bar, is omega L 90 degrees. So J represents simply it is 90 degrees there. If you have a capacitor C, we replace this with a resistance, which is J by omega C. So the reactance of a capacitance is simply 1 by omega C minus 90 degrees. So whenever you use an inductor and a capacitor, you can just dump it there. Resistor will be just like a resistor. So the complex phasor form of resistance is simply R phase angle 0. Clear the stuff. So that was the basic theme there. So let's see a few examples and then we'll bump up the level slowly. So let's do something easy. Let's say we got an inductor, we got a resistor, we got a capacitor. We have a current I. I is equal to, let's say, 10 sine omega t plus 30. XL is 10. R is 10. XC is 20. Okay. And I have a voltmeter connected between this and this. I have a voltmeter connected between this and this. Now be careful. Do you guys remember what voltmeters measure? Voltmeters measure RMS values, right? AC voltmeters, they measure RMS value. They don't measure instantaneous value. So you have to be careful. So using this data, what I want you to find the voltage across the inductor as function of time t, voltage across the resistor as function of time t, voltage across capacitor as function of time t, reading of V1 and V2. Let's see. So just to say, right, whole thing, when you convert the voltages and resistances and everything into vector forms, phasor form, you can literally use them like vectors and finish off the question. So you will see 3-4 models, so you get the hang of it. So it's little weird. Once you get used to it, right, it becomes very easy to solve most of the problems. Right. Give me a minute or two, then I'll show you the whole thing. Okay. So when you do this problem, step 1, convert things into phasors. So your current ka phasor I bar will be 10 angle 30 degrees. Your XL ka phasor will be 10 90 degrees. Remember, it should be J omega L. Now in the exam, they'll not give you J 90 and all that thing. Getting it? So that is something we created. Exam they'll simply say XL. You need to understand, boss, inductor ka resistance hoga J omega L. So resistance R bar is 10 0. Capacitance ka XC reactance would be 20 minus 90 minus J by omega C, right? So you need to convert this into phasor. So JE people, they don't have an idea what you're going to do with all this. So they will expect you to solve in some way. So then you're done. So what do you want? You want VL bar? So VL bar is simply the current into, I'll just put a dot. It's not a just multiplication there, into XL bar. So I is 10, XL is 10, 10, 10, 100, 90, 30, 120 degrees. So you want as a function of time t, this simply means 100 sine omega t. plus 2 pi by 3. That is your voltage as function of time t. Makes sense? You just finish off like that. You want V R bar, which is I bar dot R bar. So that would be 10, 10, 100, 30. So this thing will be 100 sine omega t plus 30. Then what else you need? VC bar is I bar dot XC bar. That's 200 minus 60. 200 sine omega t minus pi by 3. Now, what do you want to find? V1 and V2. So if I take this point as A, and if I take this point as B, and if I take this point as B, and this point as C, and this point as D. So the voltmeter V1 as function of time t is simply, right, the V1 ka phasor will be the current I bar into the impedance ZAB. It's all just like resistance. Think about this. If you want the voltage across these two, shouldn't I take the resistance of those two together? So if you want the voltage across A and B, then I should take the impedance between A and B, right? So, but what is the impedance between A and B? So that would be 10 plus 10J. So the phasor form is 10 root 2, 45. So current is 10, 30, the 10 root 2, 45. So that would be 10, 10, 100 root 2, meaning they're not asking us function of time t, so you don't need it. Remember, this is the peak value. But the voltmeter measures, so if they want you to find as function of time t, you can even do that. But what you want is the RMS value. So V1 ka RMS value will be 100 root 2, right, by 100. I think, did I mess up any calculations? That looks right. So that's 100 root 2 by root 2. That's 100 volts. Clear with this? So that's VR square, real square, 100 square plus 100 square. That would be 100 root 2 का RMS. हाँ ठीक है. Next, what do you want to find between B and D? But luckily, right, you could have done this also. Since you know VR, VL, VC are perpendicular to each other, you can say VR square plus VL square. That also works. You know that, right? If I try to do the phasors here, luckily, see, since all of them have same current, I, VR, and this will be in phase, VL will be this way, and VC will be this way. So if you're adding VL bar and VR bar, you can simply take the resultant of these two. But remember, this will always give you the, if you take peak values, you'll get the peak value. If you take RMS, you'll get the RMS. Right? But that would be an easier way to do in this scenario. Similarly, V2 bar will be I bar into Z into BD bar. Same story here. This time it will be 10 minus 10J. That would be 1030, 10 root 2 minus 45. So that is 100 root 2 minus 15. So yeah, you got it. So the RMS will be again 100. So both the voltmeters will show 100 and 100. Clear with this? Clear with the idea here? I hope you're getting how to convert things into the phasors. Right? So let's see one more. I should check out the notes. We did more, but let's see one of them. And not this one. This one. This one, I guess. Huh. Let's get this thing. So if it's an RLC circuit, right, you can actually use your regular stuff. You can forget about all that complex stuff and you'll still get the answers. Meaning if you know how to do the standard way. 10 minus 20j, हाँ सही है. This is 10 minus 20j. This would be 10 root 5. Some angle you'll get alpha. Tan inverse 2. Anyway, you don't need that. So this would be 100 root 5. Some angle. So RMS will be 100 root 5 by root 2. Yeah, that was a mistake. Be careful with that. Let's get this. Now, this is not out of the portion. This is still in the portion, because why? JE people will say this thing. They will say, okay, consider this as one circuit, consider this as one circuit, consider this as one circuit. Because the battery is in parallel to all of them, you can treat them as 3 separate RLC series circuits. Right? So this will not be out of the portion. There is no need to give a paragraph also. They will just ask you. Mains mein they won't do such things. Mains mein they'll keep it as simple as possible. Advanced mein they will do this kind of stuff. And you can do this using phasors normally, but that drawing that VI and all. But complex numbers is also a good way. Matlab, you're going to use mix and match. This thing looks dangerous, but it's not. Again, when they say like this, current in each branch, right? They're not asking you for as function of time t. It's always RMS. Generally, you will figure out that from the options. Think about it. In an AC circuit, if they're giving you current ka constant value, that's not possible, isn't it? In an AC circuit, current should be actually changing with time, or voltages should be changing with time, but the options are looking like solid numbers there without constant. They're asking about RMS. So keep that in mind. Until unless they specify something specifically, if they just give you a constant value, it is an RMS value. A little lengthy. Try, I'll give 2-3 minutes more. Okay, step 1, convert everything into phasors. So here VRMS is already given 100. So my voltage is 100, 0. They didn't give anything, right? So I will take 0. If they don't give anything, take 0. 100 root to 0. Now, one thing in phasors, if you want, you can put even RMS angle 0. It will give you the answers, but remember, then you'll get all RMS values only. But we will write this way because what this implies is 100 root 2 sine omega t. So you have to be careful with that. Technically, this is the right way to do it. But if they're asking RMS, you can do it sometimes. But anyway, we'll just put it up. So 100 root 2, 0. This upper one, impedance, let's call it Z1, which is 4 plus 3J, which is 5. That is tan theta 3 by 4, which is 37. The second one ka angle, let it call it Z2 bar, which is a 6 minus 8j, so that is 10, and tan theta minus 4 by 3, that's minus 53. The third one, Z3, 10 plus 10j minus 10j, so the j component is gone, so this guy is simply 10, 0. So these are the impedances in the each branch. All clear with that? And then what do you want to find? The current. So let this be I1, let this be I2, let this be I3. So current I1 is simply voltage by Z1 bar. You just use your regular Ohm's law. So that guy would be 100 root 2, 0 by 5. That 37 will go up, so minus 37. So that would be 20 root 2 minus 37. Now he didn't ask you for a function of time t. So you can just divide. This is the peak value. So you can say 20 ampere. But if they did ask you for time t, this would have been sine omega t minus 37. So the current in this branch VRMS will be, so I1 RMS is 20 ampere. Similarly, I2 will be 100 root 2 by 10, that's 10 root 2 minus 53. Ten root 2 sine omega t minus, no, plus होगा ये, plus 53. I3 would be 10 root 2, 0. This would be 10 root 2 sine omega t. Clear with this? You can get the RMS values from here. Makes sense. Then that is the first part. Next, what do you want? You want the power generated in each resistance. Cool. So what is the power generated? You can directly say I square R. So power is nothing but I square RMS. So you have to use RMS. If you guys remember, isn't that the definition of RMS? The constant DC value, which would give you the same heat as an AC current in one time period, is called the RMS value. If you remember, that's how the whole RMS was defined. So if you can find IRMS of each branch and multiply with the R in the branch, that will show you the power. So power in the first branch will be I1 RMS, which is 20 ka square, and that resistance was R1. So 20 square into 4, that's 800. So power in the second resistor would be I2 RMS square, right? And that would be 10 square, and that resistance is 6, that's 600. P3 will be this I3 RMS square, R3, that's 10 square into 10, that's 1000. Add कर लेना कितना था 2400. Clear with us? That will also give you the total power in the circuit. Just add them up. You're done with B, you're done with C. Net current drawn from the source. So what is the net current drawn from the source? So this current I is nothing but I1 bar plus I2 bar plus I3 bar. You have to add them like phasors. So the net current from the circuit is I1 bar plus I2 bar plus I3 bar. And if you remember, I taught you this, how to add three different phasors. So this guy ka magnitude is 20 root 2 and it is making an angle of 37. So this is 20 root 2 making an angle of 37. So this is your I1. I2 is 10 root 2 making 53. So this is 10 root 2 and this is making 53 and these two are 90. And I3 is 10 root 2 making 0. 10 root 2, 10 root 2. This is your I3, this is your I2. Bus, add these three vectors and finish it off. So ये होगा 10 root 2 plus 20 root 2 cos 37 plus 10 root 2 cos 53 and vertically 10 root 2 sin 37 minus 20 root 2. I am skipping a lot of steps, so you can check it out. So finish it off. जो आएगा I resultant वही है. You want even that as a function of time t, you will get it. So this is the I net ka RMS value or the peak value. So this is because I took all peak values only here. This is I1 ka peak, I3 ka peak. This is I took a peak. So when you do this, you'll get I net ka peak. If you they didn't say anything, so they're asking for RMS only. So divide that and you're done. What about the net impedance? That is the easiest thing now. So Z bar for the whole circuit is V bar by I bar, isn't it? So this will be VRMS of the whole thing, and this is the IRMS of this whole thing, and you're done. Since you know the current from the source and you know the voltage of the source, divide them and you'll finish it off. Any doubts on this? You can actually find impedance like this also. You know, this resistance, this resistance, this resistance, and all these three are in parallel, right? So 1 by Z1 plus 1 by Z2 plus 1 by Z3. You can do that. Clear with this? Any doubts on this question? I hope you understood, right, what we did with each section, each one, and everything. You should definitely try this on your own again. Can we not use power factor for the average power in the circuit? So how do you get the phase angle, right, Prakriti? The formula would be VRMS, IRMS, cos phi. Which VRMS? This VRMS. Which IRMS? This IRMS. Which cos phi? The angle between these two. Na? So yeah, वही करना पड़ेगा. मतलब you're getting the whole source again. We don't know that, right? End में तो वही आया था. We are actually figuring out Z from there. Yeah, that is one way to go. But problem क्या था ना? Second part में if you see specifically they asked you power in each resistance. You would have got stuck there if you go through that method. So because we did B, we didn't bother to do separately for the C part. But if you had asked me only C without this, maybe I would have tried that. Yeah, so that's all that way. Clear with this? Let's see one more. Let's say we have this is a V naught sine omega t. This guy is XL 10. This is R1 10. This is also XL 10, and this is R2 10. So find the peak voltage across R2. R2 is this guy. Answer will come in terms of V naught something. So you want, I could give you a number. Let's say 10 sine omega t. Big deal. I took V naught as 10. 20 by 3. So how do we handle this? See, I will just get an equivalent resistance. So I will take this guy as 1 and I'll take this guy as 1. So I'll just call this thing Z1, which is 10 plus 10J. And this thing is 1 by Z2. They're in parallel. So 1 plus 10 by 1 plus 10J. Once you convert them into a complex number, you can just simply use them like your regular series parallel. Everything works, right? So how much is this? Take out 1 by 10 common. That 1 by j will become simply 1 minus j. So this is 1 by z2. Z2 will be 10 by 1 minus j. You can factorize that 1 plus j by 1 minus j. So that is 5 into 1 plus j. I hope I'm right. So that's your whole thing, right? And then you're done basically. So I can find the current here. So what is the net system ka Z equivalent? So this current I here, I bar will be V bar by Z equivalent bar. So Z equivalent will be Z1 plus Z2, which is 10 plus 10J, that is 15 plus 15J. Not bad. So Z equivalent ka phasor form will be 15 root 2 45. So this guy will be 10 0 by 15 root 2 45. That would be 2 by 3. So that's root 2 by 3 minus 45. This is the current which is flowing in the circuit. Now, can I say this thing? The voltage across R2 is same as voltage across Z2. Because they're in parallel, the voltage across that Z2 element must be equal to the voltage across R2. You have treating this whole thing as Z2. Voltage across that element must be parallel to R2, right? So the voltage across Z2 is the voltage across R2. So how much is that? So voltage across Z2 will be the current I bar dot Z2 bar. Current is root 2 by 3 minus 45. This is 15 root 2 45. 45 45. Anyway, that doesn't matter. That would be 10 0 degrees. So this is the peak value, right? Which is the 10. Check. Did I mess up any calculations? I messed up. Where? 5 root 2. You're right. Yeah. तो कितना होगा वो 10 by 3 होगा ना. This is the peak value anyway. So now it is right. Fine, right? Calculations. ठीक है. I do keep correcting my calculations now. I am going a little fast. I'm skipping things. So you guys don't do this in the exam. But clear with the idea there, what we did? Next thing. So that is one way. You can just convert them into series parallel and you can finish off solving. 1 by Z2 is plus, meaning, okay. Next one. Now, if you can use series and parallel, that means I can also use something like this. This, I feel like this is something they can ask you. I'm not sure though. They might put some small paragraph and they can explain you. And we have a galvanometer here. So this impedance is Z1, this impedance is Z2, this impedance is Z3, and this impedance is Z4. Right? Find the condition if the current in the galvanometer is 0. So let's say Z1 is simply resistance plus an inductor. So in that rectangle box, right, there is a resistance and an inductance. Z2 is a resistance plus a capacitor. Z3 is simply a resistor. Z4 is simply an inductor. So these are the 4 elements that you have. Find the condition if the current in the galvanometer Ig is 0. Meaning I wanted a relation between R1, R2, R3, L1, L2, and C. What is this thing called? Wheatstone bridge, yeah? So this is a simple Wheatstone bridge. It works even here. Uh, Omega. I don't think you need it. Right? Cancel हो जाएगा, I guess. I think so. ठीक है, ओमेगा ले लो, देखते हैं. You will need Excel. ठीक ना, ओमेगा लेके कर लो. देखते हैं एंड में if you got stuck with omega तो ठीक है. We need it. If it gets cancelled, so it is gone. Do it, huh? Simplify. I want you to show something. There's a trap. Concept is easy. So, but I hope you got the idea, right? So what we do for a Wheatstone bridge, since Ig is 0, the bridge is balanced. The condition here should be Z1 bar by Z2 bar is equal to Z3 bar by Z4 bar. So basically Z1 bar, Z4 bar is equal to Z2 bar, Z3 bar. So this by this must be equal to this by this. So if you satisfy this condition, again, be careful. So this should be complex number multiplications. That is the only idea there. So when you add them like complex numbers. When you multiply and divide, you do like complex numbers. You just can't take the magnitude. You have to get everything in complex form. That's it. If you take your impedances in complex number form, you can use your Wheatstone-Bridge formula. Then when you do this, yeah, we will take omega. We will need it. So Z1, Z2 bar. So this guy will be R1 plus J omega L1. This will be R2 minus J by omega C. This is R3 and this is J omega L2. So Z1 bar will be R1 plus J omega L1. Z4 is J omega L2. Z2 is R2 minus J by omega C, and this is R3. Yeah, just multiply this. So this would be J omega R1 L2 minus omega square L1 L2. This is R2 R3 minus J omega C R3. Right, now the complex numbers must be equal, real numbers must be equal. So R2 R3 is equal to minus omega square L1 L2. And omega R1 L2 is equal to minus 1 by omega C R3. So from here we'll get omega square is equal to minus R3C R1 L2. From here we get omega square is equal to R2 R3 L1 L2. Then we equate them. R2 R3 L1 L2 must be equal to 1 by R3C R1 L2. So this would be the condition. Technically, this is how you solve and you get it. So if you satisfy that condition, it works. But this is wrong. Getting it? Now you should be careful with this. Now why this is wrong? Method is not wrong. Method sab theek hai. The problem was this. Omega square is a positive number and this guy here is a negative number. The reason why it worked out, right? You got an error here. You also got an error here. When you multiplied them, minus and went away. समझ में आया? You got here, when you equated omega square, first of all, this condition itself is wrong, isn't it? LHS may have a positive number, RHS may have a negative number. That itself is a wrong condition. Same here also that happened. LHS may got positive, right side you got negative. That was also wrong. But when you equated them, somehow luckily the minus and went away and you ended up with some answer. You're getting the problem there. That's it. That is the only thing. Be careful. Always ask yourself, does this equation even make sense? right? So this is not possible. That is the reason the answer is wrong. Method is not wrong. So what is the meaning of this? The meaning of this thing is IG will never be 0. For this set of conditions, IG will never be 0. So I have to adjust the value so that you get a positive number there, then it will work. Clear with this? So Wheatstone bridge, it works, but you have to treat them like complex numbers and you finish it off. That would be fine. Any doubts on this? Clear? Again, not a tough one, but you have to be careful with that. You can't equate a positive number to the negative number there. The type. So we have a capacitor, we have a switch, and we have an inductor, we have a resistor. Switch का कुछ point ले है, तो ठीक है. C, we have L, we have R, we have a voltage source. Right. So the question is find omega if the power factor is 1. Remember, right? Power factor cos phi is 1. Not omega. Find capacitance if power factor is 1. You can take this thing as some V naught and sine omega t. Let's find capacitance only. So you guys know, right? What happens if there's power factor 1? The power factor is 1 and the voltage source and the current coming from the voltage source are in phase. That means the overall impedance is what? A pure resistor. That's the main idea there. So if you can somehow find the Z equivalent, uska complex part nahi hona chahiye. That's it. If you understood that, then it's pretty easy to solve this with complex numbers. You can do this with these phasors, it will go lengthy. So what is the idea there? Like, well, let's convert this into complex numbers. So this guy would be minus j by omega c, and this guy would be j omega l, and this is r. So 1 by z equivalent will be 1 by z1, which is r1 r plus j omega l, then 1 plus minus j by omega c. Right? 1 by z1 plus 1 by z2. They're in parallel. You know how to do all this thing, right? You can simplify, you can get everything. So, and then whatever we get z equivalent here, the imaginary part of the z equivalent must be 0. But instead of doing all that, you can also argue like this, isn't it? The imaginary part of 1 by z is also 0. You're getting it? Instead of usko flip karke solve karne se better, you can find, leave it like this, get the real part, get the complex part, and then just argue with the statement. If z equivalent imaginary part is 0, then 1 by z imaginary part is also 0. You're clear with this? And so that means I need not solve for the whole thing. I'll just keep it like this. Then this guy will be r minus j omega l, and the denominator will become r square minus omega square l square. And this guy would be multiply minus j and minus j. minus j omega c something. You can simplify. I'll leave it to you. You guys are better in complex numbers. Clear with this? Or you can just flip it and do whatever you want. So basically get z equivalent and finish it off. Clear with this? So the complex part is the most easiest way to do it. You can handle that with phasors also, but this is preferable. There are some really good questions in the class notes. I should do that. I'm doing 1 or 2 from the notes and I'm showing you something else. But in the notes, especially there are last 2-3 problems which are there paragraph based. You should definitely check it out. This is 2012 JEE question. This is what I said. They will ask parallel stuff. So don't assume like RLC series. They will only say one simple argument. There, this is your RLC series. This is your RLC series. There, you got your series. But if they put a resistor here, then you can argue, boss, this is not right. Then they have to explain you something in the paragraph. Let's get this. I know answers are already marked, but solve. Get it, I'll give you 2-3 minutes. The current through the circuit. So voltage across the 100 ohm resistor. Most people still get that circuit current and all, but when they ask this, people get stumped here actually. That 100 ohm, 50 ohm is specifically when they ask. Yeah, this can be still handled with phasors, but it becomes a pain. We will see that also one question where we have to use phasors for that also. That is the monster problem. I kept it for the end. But I think here, if you see now, the numbers are good. Step 1, convert this into resistors. In case you're still wondering. Kitna the capacitance? 1 by omega C. 100 C is 100, 10 power minus 6, 10 power 4. That's 100. So this is minus 100 J. This is 100. Omega L, this is 50. This is 50 J and 50. That numbers are good. So if I take the top one as Z1, that would be 100 minus 100J, which is 100 root 245. Z2 will be 50 plus 50J. 50 root 2 plus 45. The voltage ka phasor, remember, this thing is RMS. So your phasor must be 20 root 2 0. You're done. You'll get whatever you want. This is I1. This is I2. So I1 bar will be V bar by Z1 bar. That's 20 root 2 by 100 root 2. Root 2 root 2 goes off. That is 5 and that's 45. That's your current there, I1 bar. And I2 bar will be V bar by Z2 bar. That's 20 root 2 by 50 root 2. Root 2 goes off. That's 2 by 5. 1 is 45. This thing is 20 by 100, no? 1 by 5. You're done there. You got two currents. So how to get the net current? So we have one vector making 1 by 5 with 45. You have another vector making 2 by 5 with 45. The angle is actually 90 degrees between them. So the resultant, you can directly argue the I net will be root over 1 by 5 square plus 1 by 2 by 5 square. Since it's just asking for the RMS. कितना होगा वो? That would be 1 by root 5. Be careful, this is the peak value. So I RMS will be 1 by root 10. That's close to 0.3 actually. So that's the reason the first option is approximately said. Right? So 1 by 9 would have been 0.33. 1 by root 10 will be close to 0.3. What else you need? The current through I. So the second option is gone anyway. The voltage across the 100 ohm resistor. So what is the voltage across the 100 ohm resistor? So voltage across the 100 ohm resistor is the current I1 into R1 bar. So I1 bar is 1 by 5, 45, and this guy is 100 is 0. So this will be 20, 45. So be careful. This is again the peak value. So RMS will be 10 root 2. So you are right. Voltage across 50 will be how much? 2 by 5 into 50. That's 20, 10 root 2. So D is wrong. All clear with this? So what JE people expected you to do, they wanted you to treat this as one circuit. So we have to draw a phasor for that. Then we have to draw one circuit for this. So the vectors would look something like this. So for this guy, they will say the voltage is V, the current is I, and we will say this is VL, this is a VR. Then we get one voltage source. Then for this thing, we will do something similar. Then this is I1, this is I2, this is VC, and that is V source. And then we'll say V source is same. Then we just turn the vectors and make VS horizontal, and then we get all those vectors to add up. Yeah, it is the same thing as phasors, but complex numbers will make you look it is easy. Clear with this? This is one way to do this. Then you can check the remaining in the notes. I'll not do all this. There is one question we will do one more, and I think phasors that should make it clear. This one. Give it a try. This thing is really a good one. Again, understand they might not ask you that high level questions and stuff, but make sure to do this again. Maybe spend some time after your mains exam gets over, get used to it, so that the questions will be straightforward. Then you will maybe like the previous one. If this is really not out of the world, you can handle this. Read, take 4 5 minutes. It's a worthy question. Let's see if we can figure out one or two options. Be careful. These all are RMS values. Huh? RMS, RMS, RMS. This 50 hertz is frequency, not omega. Omega is 2 pi f. Think. How will you approach? Take 3 4 minutes more. Got something. Let's see. Got something. Yeah. 5 ampere. Na? What do you think it is? If it is not, like they didn't give enough 5 naught sine omega t. Like I keep saying, you see a constant number, always it is an RMS value. You guys figure out some things? Few things. Matlab, I'll tell you, when I saw this question for the first time, what I saw was this. I said, this was 100. ये दोनों parallel है. So I don't know what is this exactly, but I can treat this as one impedance. That is also 100. This is also 100. Can you see? All three are 100. And we know, right? These things will act like vectors. That means this vector 100 and this vector 100 ka resultant is giving you another vector 100. So if two vectors of equal magnitude give you the same magnitudes, what is the angle between those two vectors? 120. You're getting it? So think now if we can figure out something, 1 or 2 points from there. So we can take the source ka voltage as V naught sine omega t is 0. So meaning if the resultant is this 100, one guy, if I call this guy Z1 and if I call this guy Z2, so this VZ1 will be here and VZ2 will be here. This is 60, this is 60. This much we can argue. But by chance, even if you don't realize that, we can use your phasors part and we'll see, we'll try to figure it out. I'll show you that. But when I saw 100, 100, 100, I was thinking, oh, okay, how is that possible? So don't treat them like resistors anymore. Think of them like vectors. That is the whole point in AC circuits. You see AC voltages, you see resistances and impedance and everything. Treat them like vectors. Should I give you another 1 or 2 minutes more? Think I'll give another 1 or 2 minutes and then I'll show you. But after the class gets over, whatever I taught you today, not much, maybe tomorrow or today night only, 15-20 minutes, just take a rough paper and try to solve 1 or 2. Yeah. But if your mains exam is on 2nd, I do understand. You can do it after that. But you have time 4 or 5 days before mains. I think you should do it by tomorrow. Neere channel. D nahi hai. First part is right. So the voltage source, I will write this thing, V source. This thing is technically right, 100 root 2 0. I will just write it as 100 0. Okay, and I'm going to write all RMS values because I think they're also asking all RMS only. I'll keep it in RMS, but getting it technically it should be 100 root 2 comma 0. Okay, so I'll just write RMS. It won't matter in the answer because NMS sub cancel ho jayega, but ideally you should always write 100 root 2 0. ठीक है. So let's call this guy Z1. Let's call this guy Z2. ठीक है. VBC and VAC. Okay, let's start with the phasor part only. So I will take my this thing as V source, which was 100, RMS 0. Now the other one, I have now the current which is flowing, the current also, right? I will take it as I, that is also 5 RMS, some phase angle 5. I don't know how much is 5. Current won't be in phase, no? There's no guarantee. So let this be current ka phase angle phi, where phi is the phase angle between the V source and your I source ka current. Perfect. And the next thing, VBC. VBC is nothing but I source phase angle phi, and you can clearly see that's an impedance XL 90 degrees. So this would be I source XL 90 plus 5. And this I into XL, this was given as 100 RMS, isn't it? So you got one step there. So I RMS is 5, XL is equal to 100. So I got XL is equal to 20 ohms, but XL is nothing but omega L. Omega is 2 pi F, F is 50, 20, so L is equal to 0, 0, 1 by 5 pi. 50 million, ये तो नहीं है, ये wrong है. That much we can see doing that. You're getting it? Matlab, if you see, right, I didn't do any big phasor geyser, kuch nahi. Just by looking at this, you can see this. IRMS into XL is 100, isn't it? That was the easiest part there. So anyway, if you see the angle must be 90 plus 5. So the angle between the current and this thing, this is 90. Who is this guy? This guy is VBC. Perfect. What about the other guy? Other guy is VAB. I have no idea how this guy looks. VAB, let this angle be alpha. Now this guy is also 100 and this guy is also 100. Now we know the vector V source is nothing but the vector VAB plus the vector BC. And you can clearly see this guy is 100, this guy is 100, and this guy is the resultant is 100. This is only possible if the angle between the source and this thing must be 60 degrees. So that means 90. So if you have two vectors, let's say some 100, and you have this vector 100, and this is the resultant, which is also 100. This is possible only if these angles are 60. So that means from here you can clearly see 90 plus phi is 60. The phi is actually minus 30. So current is not leading, current is actually lagging. And alpha is also 60 degrees. Perfect. Got many phase angles. So without doing all that, right, you could have simply argued, boss, this should be 60, this should be 60, 60, 60, directly draw kar sakte the na? If you had realized it is a vector. If by chance you didn't realize, then this is the way you would have still proved it is 60 and 60. Either way, vector ka logic to use karna hi padega. So great. Once I got this, now let me draw the new things again. So this was my V source, 0 degrees. Now just now we proved this was the current source, which was minus 30. So this angle was 30. This was your VAB, which was 60. This was your VBC. I think that was BC, right? That was BC. Basically, this is the inductor one. This was AAB. This was also 60, meaning this angle must be 30. Perfect. I think I got. You want to find the power? What is power ka formula? Power is VRMS, IRMS, cos phi. Yaad hai? I know VRMS, how much? 100. I know IRMS, phi. What is cos phi? This is the angle between them. So phi is 30 here. That is the angle between the voltage of the source and the current in the source. Let's cos 30. So that would be 500 root 3 by 2, 250 root 3. I think वो जब solve करेगा तो 433 approximately तो आएगा. 430. You'll get close to 430. That's your first option. Next thing, he's asking for the capacitance and the current and the voltage VBC by 30. How do we handle that? So again, little work there. So we have that capacitor there. We have the resistor here. Try to understand. This current is your I source, which is making minus 30. Let this current be I1. I'll just put it as IC. Let this thing be IR. And across this, the voltage is 100. This was AB. Perfect. So now listen to this thing. So current IR will be nothing but voltage across AB by R, right? R is anyway 0, right? That means in this picture here, if I see this, so this is your I source. I just add up here. So this must be your IR. Making sense? So across that source, no, not that one. My mistake. Wait. I'll just put a new picture here. Now look at this thing clearly. Just look at this thing. So we can clearly see the IR vector is parallel to VAB vector because iska to angle 0 hai na R ka. That won't change it. So where is VAB? VAB is this guy. So your IR will be this one. And you can clearly see this thing is purely a capacitance IC, which is VAB bar by whatever is that. Capacitance is XC minus 90 degrees. So when it goes up, you get VAB bar by XC 90. Right? And this would be 0. That means IC is perpendicular to VAB bar. So for this AB line, I have to draw a perpendicular. So 30, 30, 60. This would be your IC. IC and IR are perpendicular. Making sense? So like I said, you're all treating like these vectors. So this IC here, it looks something like this. But tell me one thing, this IC bar and this IR bar, when you add them vectorially, shouldn't the resultant be I source? Because I source ka vector form is IR ka vector form plus IC ka vector form. But we already know from here, the angle between I source and VAB is how much? This is 30 and this should be 60. And we know this current is 5. So ye kitna hoga? This will be 5 cos 60. Or ye current kitna hoga? 5 cos 30. You can actually find the current in each branch once you get the vector form there. Clear with this? And then you're done actually. Once you got this, so you want to find that capacitance. So voltage across AB must be equal to the current in the capacitance into XC. Voltage across AB was 100. And what was the angle? 60. Anyway, you don't need the phase angles here, luckily. So this would be, so XC will be VAB by IC. VAB is 100. IC will be 5 cos 60. That would be 40 ohms. That was your second option. You can even find the resistance. They didn't ask you, but if you want to find the resistance, then you can say VAB is equal to IR into R, right? So resistance will be 100 by 5 cos 30. That would be 40 by 3. That is the resistance R. You can literally find the values of L, R, and C, everything here. What is the last option? The current in C is leading the voltage by 30 degrees. So what is the current in C? VC, and leading the voltage of BC. This angle here is 30 degrees. So tell me, is IC leading or lagging? IC is behind, right? IC lags VBC by 30 degrees. It doesn't lead. It's behind that. So the fourth option was wrong. Clear with this? So I hope you can see phasors. How phasors mein kya tha aisa ho? Matlab you have to take this in vector form and you have to keep checking the angles. So the main idea is I took the source as 0 reference. Okay. With that as a reference, I started putting every other vector. You should definitely try this, not because they'll ask the same problem, but this will make your concepts, clear, like kaha pe kaisa lena hai, what is the meaning of vector form, what you're doing. So you do everything same, the junction law is same. I is equal to I1 plus I2, but make sure I1, I2 are vectors. right? Voltages will be same. In series, V voltage is V1 plus V2, but V1 and V2 are vectors. So that is the main thing you have to get into the head. You have converted all these into vectors and you're just playing with vectors, right? It might be a little overwhelming, but whatever problems we did, you just do them again once or twice next week. That should be sufficient. You'll get the hang of it. AC circuits, right? Is a like I said, there are one or two paragraphs in the notes. Check them out. I don't think they can go beyond this. You should be able to handle most of it. Clear with this? Take a small 5 minute break. Come back. We'll continue from here again. Any doubt so far? Hmm. Let's get this. So this is one more important thing, LC oscillations. Those are quite an important thing because you can relate it to SHM, right? And later on, I'll show you something. You can relate RLC circuit to damped oscillations. This is a kind of a question I think, if you realize it's pretty easy. If you don't realize it's a mess. Question is big. Read. Meaning, tell me one thing. Forget about reading the question. If you just see the circuit, what is the first feeling you get? How do you guys read a question normally? I'll tell you how I read. When I see the question, right, I will, if I am reading this question for the first time, I'll see like this thing, okay, circuit, capacitor, potential. I'm not even reading the question. I'm just picking words. Okay, S2, S1, okay, दो switches है. C2, okay, C2 यहाँ पे है. C1, okay, यहाँ पे है. Coil is inductance, okay, inductance है. ठीक है, मतलब I didn't understand any shit about the question. All that I came to know in this 10-15 seconds is like, okay, there is a circuit with two capacitors and an inductor and two switches. Now, with whatever limited knowledge that I know, the first thing that comes into my mind, energy is conserved. One, that is the first thing. Second thing, this is an LC oscillation. Right? So you need to understand, so what you're trying to do, right? You're trying to narrow it down to the things, because see, physics mein itna concepts hai. Your brain should know, boss, where should I focus, right? This is not a thermodynamics problem. So why you want to go and remove every damn concept from every chapter? Narrow it down. So I know, looking at the circuit, this must be LC oscillation based, EMI chapter, LC oscillations. In LC oscillations, energy is conserved. Bas itna mujhe idea tha. Now I'll read the question again. Now you have a context. Read the question again properly. You will understand most of it. Then try to fill up the gaps again. Maybe you have to read this question 2 to 3 times. And then if you figure out, it is great, or else we'll see. Let's see what you will do after that. So when you read a question, normally you need to read it minimum 2 times. People do it normally 3 times. So the first reading, I do that. I just skim on the surface level just to get the data, what is there. Second time and third time, I read it properly. Because if your brain has a context, right? Oh, I am thinking about an LC circuit, and then you read the question, it will try to fill the gap. What most of you do, you start reading the question from the beginning and try to fill it. Brain ko idea hi nahi hai. For brain, it is like this. You're going from A and you don't know where to go. So it doesn't understand which concepts to connect. कभी Google search try किया? I want to go to, बस टू छोड़ दिया उसके बाद it will start giving you options. I want to go to Goa. I want to go to and jump from a building. I want to go beat someone. It will give you 10 options. मतलब, right? So it is trying to figure out what the hell are you thinking. It could be any nonsense. So having a context is important when you're reading a question. So when you know this is an LC, and when you're reading, right, your brain is picking out all the concepts from LC ka and energy and SHM, and it'll try to keep on relating it. At least I found that is easy. And this is something you can't learn in 1 or 2 days. You still have a 1.5 month time. So you need to practice this deliberately for 4 or 5 tests. You'll get the hang of it in 5 to 6 tests. Go through it. This is the kind of question they can ask in advance, which will scare 95% of the people. 4 to almost, maybe around 0.5% people figure it out. 4.5% people will struggle. They try to make equations and everything. So let's see, do you guys figure it out? Initially, capacitor of C1 is charged to potential difference V0. Okay. Switch S1 is closed at time t is equal to 0. S2 is open. So forget about S2. So this thing is simply oscillating in, out, in, out, in, out. Perfect. Then at time t is equal to S2 was opened. No, wait, which capacitor did you charge? Did you... After some time, S1 is opened. Okay. And S2 is closed simultaneously. So you opened it. So at that point, when you opened it, whatever current is here, that will not change, isn't it? And whatever charge here, that will not change. They got disconnected. Now this current will try to go inside this capacitor trying to charge this capacitor. This will start oscillating, isn't it? In, out, in, out, in, out. I hope you figured out till that part, isn't it? That's like your transferring from here to here. Great. And he said, found that the potential difference across the capacitor C2 is C0 by 9 was 3V0. Okay, find the smallest possible. Now, when I look at these numbers, right, when I actually did this question first time also, I saw this number C0 by 9, I saw 3V0, I said, yeah, this is looking like half C0 by 9, and if you take 3V0 square, that 9 is cancelling out, so this is half CV0 square. And the energy initially here is also half CV0 square. Meaning this is only possible if this guy was completely empty, he transferred all the energy to the inductor, right? And then this inductor transferred all the energy to the capacitor. Making sense? And when does that happen? Now, if this is an LC oscillations, right? So you're done basically. So this thing energy was initially half C naught V naught square. So this was your initial energy. And this thing was half C naught by 9 3V naught square. This is also half CV naught square. So all the energy from C1, it got transferred to the inductor. So basically it is like an LC oscillation, meaning this will be how much time? This will be T by 4, isn't it? 1/4 of a time period. If you remember spring block system, how much time does it take for the kinetic energy to become potential energy? 1/4 of an oscillation, isn't it? Remember that in LC oscillations, in 1/4 of an oscillation, you go to the extreme position. So all your kinetic becomes potential. So this must be T by 4. And then from the inductor, all the energy went into the C2 capacitor, and this must have taken another 1/4. Yeah, but the difference is this is T2 and this is T1. And T1 is nothing but 2 pi 1 by root LC1. T2 is nothing but 2 pi root over LC2. The answer is 1 by 4th of each, and you're done. Are you clear with this? So in 1/4 of an oscillation, you removed the switch, the capacitor got fully charged. 1/4 of that oscillation filled up the capacitor. So the total time would be pi by 2, 1 by root LC1 plus pi by 2, 1 by root LC2. So basically it is like, if I have to convert this into a spring block system now, everyone, this is how it looks. We got a block here. This is the mean position. This is x is equal to minus a1, right? Let's say this is k1 and this is m. And here one more block is sitting, m, but this spring is k2, right? So the question would be like this. If it is released from here, in how much time this spring will have maximum compression? Isn't that the question? So this block from here will come to this position with a maximum speed, right? And remember, this is the mean position. So then when these two blocks collide, this block will come to rest. Because it's at the mean position, spring is in natural length. Now this guy will go with Vmax and this will try to compress the spring. And this spring will get compressed and this will come to rest. So the question has simply become how much time will it take? So this will take T1 by 4 and this will take T2 by 4. Where T1 is nothing but 2 pi root over m by k1. And this thing T2 will be 2 pi root over m by k2. Now it is making sense, the comparison. So the main thing, right, was figuring out that this is C naught by 9 and 3V naught. Then it's pretty easy. If that was not true, yeah, then it would have been a fight. We could still figure it out with SHM, but yeah, we still have to do a little more work. C1, C2 का values पता है तो substitute कर लो and you're done. Clear with this? Now, in the notes, there is one really another type of question here. You should, like I said, notes में there are multiple models in EMI. You should thoroughly do it, like, just like you did for rotation. Right? We don't have the bandwidth to each and everything, but it's a really worth a thing. कहाँ पे है वो? This guy. We had two capacitors and one inductor. ये भी LC oscillation था. Right? So can you just write the equation? Just the equation. Let's say after time t, charge q flowed from here, इसका q minus q हो गया. Just write the equation and tell me how will you get the time period. Let's say charge q went from this plate, this became q minus q, and the current is I. Just get me the equation in that. This is one problem you should definitely check out, LC oscillations. Just like rotation is a chapter for mechanics, EMI is a chapter for entire electromagnetism. Right? After the mains exam gets over, you feel like you don't have enough time to do everything, I would strongly say do your entire electromagnetism properly, thoroughly, each and everything from the notes. And I think you really won't have time after mains. Like, uske baad bits and everything is there. I would strongly suggest you just stick to the class notes, right? Do them thoroughly and advance ka revision notes, right? If you're thorough with them, you're able to do each and every problem in the notes, then great. Then go ahead with more materials. There's no point in doing more and more at this point. It is all about consolidation now. Last 20 days should be all about consolidation. कर लिया equation? So if you do ना, ऐसा दिखेगा equation देख. Q minus Q by C, L dA by dt minus Q by C. So when you write this equation, then this is the form you get. And this is your SHM equation. The whole question becomes an SHM question. You can get literally everything, you'll get it from there. You know what is this question like? This question is like two blocks with a spring. Every LC circuit you can connect it to a spring block system. And you can look at the comparison here. Dekho, F is equal to Kx, flux is equal to Li. E is half Kx square, E is half Li square. So the inductance looks like spring. The compression looks like current. So in two block problem, when do you get maximum compression? When both the blocks have same velocity. So in this question, when do you get maximum current? When both the capacitors have same potential. You get in the relation there. You can combine things like that. You can always create a system like that. So this is one thing you should definitely check out. Right. So again, if you actually realize it was a pretty easy question, but realizing part was the thing. Let's see one more. This is some Olympiad ka thing. This is an INPHO. Long back, 2008. These are the kind of problems that will scare everyone out. Meaning, forget about INPHO on the top, but if you just see the rest of the question, you feel like, what the hell? This is another type of problems they can definitely ask in advanced paragraphs. Quite practical. Like, this is an experiment to actually find speed of light. Go through it, read it. I'll give you 5 minutes. Most people will see this and will leave the question without even reading. They'll get scared. You should definitely do it. The more scary it looks, the more easy the questions are. Okay, let's see. So if I'm reading the question again, what I would try to do is just scan the question first of all in the circuit: average electric force, capacitor, average magnetic force, rings, derive an expression for velocity of speed. Shit, this is what I would think. First, I will read speed of light and I'll say, what, what the hell is he asking? Like, I said, ठीक है. Then it's estimate the speed of light. A का value S is there. Okay, ठीक है. I mean, I need to read the whole question again. So I'll read it again. Then again, see, don't worry about the question. Always it is about mining data in the beginning. So he's saying the average force, average magnetic force are equal. Okay. Capacitor. So the first thing I'll think is, okay, what is the average force between plates? याद है? Q square by 2 epsilon. So that's what I'm saying. You hear the words, you keep getting the things which are required. Average magnetic force between the circular rings. Rings. I don't know any formula for this. Think about it. Do you have any formula for rings? You have formula for parallel wires. You have formula you can derive, and they're perpendicular like this. Rings we never did. So ठीक है. Ignore the effect of gravity. Derive an expression for velocity in terms of light. ठीक है. Estimate the speed of light given A, B, and everything. And I'm thinking like, why do you think he gave you this? To neglect fringe effects. If you remember, normally for parallel plates and everything, we keep them very close. For finding magnetic force, rings can be treated as long wires there. That is one problem are solved. So he's saying indirectly was just treat them like parallel wires and finish it off. And parallel wires का formula क्या था? Mu naught I1 I2 by 2 pi d into L. So now I'm wondering. So he's saying this guy and this guy is equal. So I'll find them somehow. How the hell will I find speed of light from these two? So that is when you should think, okay, so for speed of light, then you'll start thinking about speed of light, all the formulas you know. So if it clicks, great. Speed of light, there is an important formula, 1 by rho naught mu naught epsilon naught. Yeah, this thing I told you multiple times. Units and dimensions, it's a very important question at a mains level. So indirectly, what is asking you is to get epsilon from here and get mu naught from here and then dump it there and get the answer. That would be the last link to click. So अभी ये सब एक के बाद एक connect होना चाहिए. Right now. Now, once you figured out till there, the question becomes pretty easy after that. Like I said, it is only to put the scaling thing. You should realize this guy. And like I said, rings, there is no idea. But last line, if you had read carefully, that would have solved your problem. Okay, now if I look at the circuit here, this guy is actually a cos function there. And anyway, if you observe here, both the circuits are in parallel. So perfect. So I can do that. So this was the capacitor. This was your source, which is V naught. I'll just write cos omega t for now. So this will be charge q. This will be minus q. So we know q is equal to c v naught cos omega t. So the force will be q square, which is c square v naught square cos square omega t by 2a epsilon. He's asking average value. The average of cos function is half. So that would be half of c square v naught square by 2a epsilon. Now this is a wire, this is a wire. Again, same story there. Current I is flowing, both are parallel. So force between them will be mu naught I by 2 pi d, and the length of the wire is 2 pi r. This is the length because you're treating like parallel wires. What is I again? I is ignore the effect of gravity, wire का resistance, inductance. Wire resistance, inductance, expressions, of line. H is given, B is given. I need to find the current there. Capacitor का तो ठीक है. Current. Oh shit! Actually, if you see, there's one more capacitor sitting here. That is what is giving the current. Wire से current कुछ नहीं हो रहा है. This C2 is sitting there. So this current I2 here is because of this guy. So this will give you charge Q2, which is dQ2 by dt. And that Q2 is nothing but, again, CV naught cos omega t. That will give you the I2 there. So this is I2, and uska bhi average na, you will get that only. Mu naught I square 2 pi d 2 pi r ka f. So do all that stuff, get mu naught from here, get epsilon from here, and then you argue with the root over 1 by mu naught epsilon naught. You actually get a pretty close to you almost get up to 2 decimals answer, right? So this is one of the way they could have figured out speed of light. Again, there are a lot of assumption, everything, but you saw the question, right? It was doable. It doesn't click. Matlab, you read the big question, you see speed of light, the words are scary. These are the kind of questions you can expect. Because their purpose is not to ask you something so wild. Meaning, frankly, if you ask me, this would be really like you're just crossing the boundary there. This problem that they ask you, at least they had to give this as a paragraph or a matrix matching. This question for a more than one choice is like injustice. You can't do this in 4 minutes. 4 marks ka question. This is not. It's not worth doing this question for 4 marks. But the problem is you will realize this only after the question is done. Right. So that way. Clear with this? So makes sense? Question is clear? Great. Those are the few ones. And there is one more really good question. We did this in the class notes, but I really want you to do it again. I don't know if you have gone through the notes. LR circuits, you can just revise it, right? It's the same as that RC ka thing. You can take that equivalent and finish it off. This question, right? I don't know whether you revised it or not. It's one pretty good question. Go through it. This explains how does an inductor and a capacitor work like. So what is the catch in these kind of questions? So the thing is, how does an inductor and a capacitor behave? So think from this perspective, okay? An inductor will always try to maintain the current. Remember inertia, we keep saying a moving thing will always keep moving. A thing which is at rest always tries to keep at rest. So an inductor will, if it has a current flowing through it, given a chance, the inductor will say, boss, I want to maintain this current. Similarly, a capacitor will say, boss, I want to maintain this charge. Yeah, they will decay after some time, but instantaneously when you just open the switch and do something, the inductors will not let the current decay to zero immediately. It takes time. So in this question, he's saying, this is an ideal voltmeter, right? So infinite resistance, you can take it as an open circuit. Did you guys try? Should I give you another 2 minutes? Try. I'll give another 2 minutes. I'll just show it in the notes anyway. It's a very good problem. So the main idea is that if you open the switch, the current in the inductors cannot become zero instantaneously. So the first step in the question was to find the currents in steady state when the switch was closed. You need to find the current and you need to find the charges on the capacitors. नीचे आंसर्स तो हैं. See, check out in the notes. In the class notes, there are questions which I'll mention. You should definitely go through them. There, so this was the main thing there. When the switch is open, the inductors will try to maintain the current and capacitors will try to maintain the same charge or the potential difference at that instant. So, initial picture. Ideal voltmeter, R is infinity, so you can ignore this. You're writing in steady state. In steady state, what happens? Capacitor behaves like open circuit, inductors become like wires, right? So current will flow which way? Look at this picture here. So current is flowing here. You cannot go through the capacitor. So this capacitor is gone. So current will go through the inductor. You cannot go this way also because capacitor is gone. You can't go this way because this capacitor is gone. So the current has to flow only in this triangle. Clear with that? So in this triangle, there is only one resistor. So current I is equal to E naught by R. Once I got the current, then I'll apply Kirchhoff's law in this loop and Kirchhoff's law in this loop, and that will give me the charge on both the capacitors. And if you observe, I got Q1 0. Obviously, if there is no current here, this thing basically got shorted, isn't it? So इसमें potential difference 0 था, so Q1 0 हो गया. इसमें potential difference is there, so these are the charges and the currents in the inductor. So these are the currents and these are the charges in steady state. So if the switch was closed for a long time, this is what you would notice. Clear? Now what you did, you opened the switch. Now if you suddenly open the switch, the current in this branch will become 0. But what will the inductors do? Inductor will say, boss, I want to maintain this current. So this current which was traveling this way, right, it cannot go here anymore. So it will try to divert into this capacitor. So the inductor will start charging that capacitor. And this current here will flow here and this will try to charge this capacitor and it will make an atypical loop. You're getting how the current starts flowing? At least that is how it behaves, as if it is going in an atypical loop. Because at this junction, right, the currents can distribute however they want. So the circuit becomes like this. So this current which is going straight will come down, then it will go this way, and then it will go this way. So there you got an atypical loop. So the current will actually simply divert. Again, remember, T0, charges will not change, current values will not change. And then once you got the current, and you can apply Kirchhoff's law between P and Q, between this and this. I'm applying in this junction here. Yeah, you get the value minus 12. At that point, it becomes pretty straightforward to solve. And then what about the heat produced? Heat produced will be all the energy in the system. What is all the energy initially? There is one inductor here, there is one inductor here, and there are one capacitor here, isn't it? The energy in these three systems must become 0 in the end. So that must be the heat produced. So 2 half Li squares and half Cv square. They can even ask you the ratio of power. Since the current is same in 4R and this R, the power will be in the ratio of 4:1. Clear with this? This is a question where there is no integration, nothing, right? Only inductor, capacitor, and steady states, and you can really do a good one. This thing is. So this is not max-oriented question, but you really need to know the steady states and everything. It's a pretty doable question, and it's a paragraph, so it is worth doing for 8 marks. Right? So that is one. Now in this notes, right, there are certain problems you should definitely check out. If you ask me, they should go through the whole chapter, but this is one question. I should definitely check it out. Remember the idea there? When you say EMF is, d phi by dt, the problem comes this way with Faraday's law. It doesn't tell you where is the EMF. Faraday's law gives you only EMF in the complete loop, right? So you should check it out. So we will get the current, but we don't know where is the EMF. So the motional EMF will tell you where is the thing there. So this was the motional EMF actually. So the EMF is occurring only in AB ka branch. There is no EMF in the remaining 3 branches. So this is one decent question. This thing though, I told you, this is like a capacitor, resistor. This is like, viscous force. This is a constant acceleration. Then we have that inductor thing. This rotating rod and stuff. I did this in mains also. Projector length. These questions are important for mains perspective. Ring is rotating, find the EMF across this. This is another good question. Rod is rotating, find omega as function of time t. And induced electric field, right? You should definitely check out 19. Field is suddenly switched on and the disk starts rotating. You can note it down, meaning this is 19, you should definitely try on your own. Write down that number, 19, check it out. 20 you should definitely do. This would be a really good question. Solid question, right? It's really worth it. And then this is also good, 121. Then these inductors and all that stuff is fine. That's what we did in the class notes. LR may this thing there. This is the thing which I showed you now. So 27. So we did it, but you should do it again. This LR circuits, right? You can just do this one circuit 29. ये question याद है? In RC में I just kept a capacitor here. It was the exact same circuit. I replaced that. And remember how we do this thing? We'll use a general method. A is equal to A plus B e power minus t by tau. Remember, finding time constant, find the initial condition, find the final condition, substitute, and you'll one. So you can do one question. It helps you. In this question, right, 30 ka C you should try. This will be a good mains question. 31 also you should do. What happens if there are 2 inductors? But this idea is good. Huh? Remember what I told you just now? The inductors will try to maintain the current. So see what happens here. When you connect it here, the current will be V by R. Now you're flipping the switch from A to B. Now what happens? L1 will say, boss, I want to maintain the current. L2 will say, I don't want current. Unlike a capacitor, inductors are not good with each other. They start fighting with each other. So you actually start getting a lot of sparks and you lose energy. So there, we did a very good proof here. You should check it out. So the whole question, right, end of the day, it looks like as if flux is conserved. There is no concept like that. There is no concept called flux conservation, but the answer looks like that. Should check out this also, 31. LC oscillations, it is fine. This one you can do, 33. Mutual inductance is fine. Last time I taught you series parallel, so hope you have gone through it, the coupled circuit and all that stuff. So yeah, those are the main questions you should definitely check out in that. And AC may you'll be able to handle everything, most of them. Just go through this resonance circuit. Huh? This question I wanted to do. Question 17 in AC. So that is one thing there. Yeah, that's a little about that EM and AC. So there are few more good models. You should definitely check out the notes. Okay, with that we'll wrap up for that day. Right, I'll see you guys again after the mains exam. I think that would be, we'll have a break for almost a week. So I'll see you guys again on 10th of April after the last mains exam gets over. But don't think like, if your exam gets over early, it is a good thing. If it is late, that is also a good thing. Either way, it's a good thing. Think of like that. Right? If your exam is getting over early, then start revising all the advanced topics. Whatever we have done, you need to revise them. Like I said, it is a time for consolidation. There's no point in trying to do a lot of new